All right, pre-calc, we are going to do some exciting stuff with our next set of graphs. We have tangent and cotangent, secant and cosecant. So they're going to look a little bit intimidating because they look a lot different than what we're doing. But I'm going to step through. A lot of this is going to be in Desmos, so you can kind of follow along, and I'll put the link in here. Okay, there are a couple things on the graph for conceptual. Just have what we have going on is these graphs all contain asymptotes, right? They're going to be vertical asymptotes, so undefined locations, because sometimes we had zeros, and when that happens in the denominator, because remember tangent is going to be y over x, which is sine over cosine, so that's going to be a big deal in a little bit. The amplitude, the a value, doesn't really change anything for us here because, well, you'll see how that works. So it takes care of those two blanks there. I got some more blanks here in the bottom of this one. So if you want to pause it there, you can do that and get those filled in. Okay, but I think the first thing is just to have this make sense, and then we'll deal with it that way. So we said tangent, right, is y over x, so it's a lot like slope. Remember, it was cosine of x and then sine of x, or theta, as we worked with the unit circle. So this means we have sine of x over top of cosine of x. Right, so our goal is to graph cosine of x. All right, and then we're going to shoot back to this page as needed. Okay, but that's idea number one. So let's take a look at it. So cosine of x, here it is. All right, and remember, we're already in radians, so all these things are going to be hunky-dory. Now, the reason we did this is I want to identify any place where I have x is 0. Right, so anytime that I have a 0, say here's pi over 2. So notice this is going to work out very nicely because normally we had worked with 2 pi to be the end of the whole thing. So let me get rid of this one. So we wanted our 4 marks, and here they are. That's what we normally work with. Now we're going to add in the points to the left. Okay, but I'm really going to focus on the zeros at this point. So what we have going on here, these are going to be 0, so our vertical asymptotes go in here. So let me put those in just for one little segment here. Okay, so the next thing we want to do is also realize that at 45 degrees, remember 45 degrees, root 2 over root 2, that is going to give me 1 all the time. So that 45 degrees, I'm trying to find out where I get 1. Okay, and let me put tangent on here so we start to see what that graph is going to look like. All right, so here is that. Nope. Trying to get to 1. You little stinker. Oh, I never remember what I have to do. Okay, so let's get our horizontal line in. All right, so if I find this intersection right here. All right, so here we are. Pi over 4 and 1. And I can also put the negative in as well. Okay. All right. So here's the process. All right. Because that was a lot. All right. I tried to make this look nice and fancy and all those things. So normally we start with cosine, right? Notice I left the horizontal lines in there. I have zeros in here. I could put them in at every pi that we deal with that. Okay. Because this would be a whole nother period the whole way out to here as we look at it. And then what I'm going to do is work within these vertical asymptotes, okay, because that's where my zeros are. And I notice that it's always going to go from left to right. It's going to be increasing. And since it is cosine, it's going to start, or for a tangent, it's going to start through the origin here. Okay, so that is the middle of my 2 zeros, and it just happens to be the origin. Okay, so the point we were looking for was this one here, and we get the same thing back here. So we're normally working with 2 pi, so we're going to shorten that up to pi over 2. So of course, half of that, right? We've got used to moving things around, pi over 4. All right, so let's sketch a few things and walk through that ourselves here. So I'm going to zoom in a little bit more and try and take care of a few things here. So first thing is graph a cosine. So 1, -1, 1, 2, 3, 4. See if I can't space it out just the right amount here. 1, 2, 3, 4. Okay, so this is 2 pi. So this is pi. So it's pi over 2. And negative pi over 2. So let's get first our cosine. And 1, 2, 3, 4, 5, 6, 7, 8. All right. So we get the whole thing. We really haven't drawn on the left side, but we're going to do that here just to get a nice graph. So any place that you go through the x-axis, vertical asymptote. Vertical asymptote. All right, so if you want to use a line tool to draw nice straight lines, that would probably be helpful. I'm not doing so good with that. All right, so that's the first item. And then the next thing we have to realize is what function we're dealing with. Okay, so since I'm dealing with tangent, okay, so tangent, remember we had square root of 2 over the square root of 2 was at 45 degrees, which was also at pi over 4. So here's my pi over 4, and that's going to hit 1. And if I marked negative pi over 4, now I'm intentionally putting up here because it's going to give me negative 1. Okay, so I'm going to hit these 3 points and then stay within those vertical asymptotes. Okay, this is simply going to repeat and repeat and repeat. Okay, so if I can get my spacing just about right, get these taken care of. All right, so I'm trying to be extra careful here. All right. Some kids think the tricky part is the ends, right? So we have to move those around. So the right side is always going up, the left side is always going down. So just watch those on the end. But that's how we graph the tangent function. Yeah, it's not as bad as we made it out to be. All right, so what happens when we then make it cotangent? Well, what is cotangent? I know, awkward pause. Remember, that's cosine over sine. So let's go back and check out this Desmos because you saw I had some extra stuff in there. Let's take some of these out. Let's take them all out. Very slowly, apparently. All right, so we know the amplitude of the original function is still 1 and negative 1. So I'm going to leave those on there. Now, notice what happened is since sine starts at 0, that's going to move all of our asymptotes. Okay, so every place that I have a 0, let's see if I can get a couple of these on here. Right, these are going to be my vertical asymptotes. And we're going to work the whole way left to right from negative 2 pi to pi again. Okay, so let's go ahead and throw cotangent in here. And I think the next two that I have are some vertical asymptotes. So we can really isolate one section right here between 0 and pi. Okay, so notice that it has been flipped over. Okay, so everything's been moved over from what tangent was, but also flipped over. Okay, so same process. Just the way I clicked on these, that's exactly what we're going to work on here, guys, as we work this whole thing out. Let me get tangent or cotangent out of the way. Okay, so sine's on the bottom. So that's what we want to graph first as we deal with our graph. So 1, negative 1. We're dealing with sine. It's on the bottom. 1, 2, 3, 4. 2 pi, pi. So we'll put these in to get started. Negative 2 pi, negative pi. Ooh, that one looks really bad. Sorry. So we got this kind of continuing. All right. Next thing is if it hits 0, vertical asymptotes. So we're going to be in between there for all of these. And same thing. We're talking about root 2 over root 2. So still on our 45s, but notice what happens is they're going to flip-flop. let's get a color that's going to show up here. Okay, or if you just remember tangent was always increasing, then cotangent's always decreasing. All right, so domain, we have some problems, right? Because we have some vertical asymptotes. But the range we're going to consider to be all real numbers, because it will go up and down forever. It's just locked into those vertical asymptotes. So those are some of the items we talk about in here. Okay. All right. All right, so that's our tangent and cotangent. We're going to pause it there. That way you can kind of take a look at those and take a break from those. As you make any translations, what we do is translate them to the primary function that we're going to work with, cotangent being sine and tangent being cosine. And then that phase shift or anything else moves all the zeros, which dictates where the graph's going to go. Okay, so it won't be too bad. So let's pause here and put this in two parts.